My name is Beyang Liu. I'm the CTO and co-founder of Sourcegraph, and I drink my coffee black.
Hello and welcome everyone to the MLOps.community podcast. I am your host, Dimitri Os, and I'm flying solo today, talking to Beyang. Wow, what a conversation. I loved his idea of context is all you need. That is all I'm going to say because I do not want to give away too much. He's been working at Sourcegraph for the last 10 years, building it out, absolutely crushing it. And recently they released Cody, which you may have seen around different code bases, or you may have actually played with it in your own code base. It's this way to query and level up your abilities of understanding the code that is in your code base. I want to give him a huge thank you because this conversation was just spot on. They brought large language model capabilities into Cody, and he was an open book about how they've been using it, what the hard parts have been, his vision for what it could be in the future, and even what a developer could be in the future. I loved the little roads and side quests we went down today in this conversation. Let me know if you like it by liking and subscribing, and of course, leaving a review. It would mean the world to me. Share this with a friend if you're feeling especially nice. And without further ado, let's get into this conversation. Beyang, you started Sourcegraph 10 years ago, you told me. What were you doing before that?
Prior to that, I was a software engineer at Palantir Technologies, which I think most people have heard of now, but they do large-scale data analysis for government and large corporations.
Yeah, and so then what gave you the inspiration to do Sourcegraph?
The inspiration was, I think, twofold. One was, as with many developer tools, I think part of it was just scratching my own itch. When I took a step back and thought about like the day-to-day pain points of software development, I realized that I was spending an inordinate amount of time trying to read and understand and make sense of the code that already existed and just like figure out heads or tails what was going on there. So I really wanted a tool to alleviate that pain. And the second thing was actually our experience at Palantir. So I met and worked with my co-founder, Quinn there, and we were on a team which was essentially drop shipping into large enterprise code bases and trying to build software effectively in that environment. And that was really eye-opening because it was, as you can imagine, extremely large, old, and complex code bases. And the pain points were even greater for the software engineers that we were collaborating with on the customer side.
You must have seen every type of code base imaginable. I can only do you have war stories from those days?
Yeah, definitely. So we were working with a lot of kind of like financial services and banking clients at the time. And what was mind blowing to us is, some of these, when you think of like software development pains, I think most people think of like, like you had to get merge conflict and I have to go through and like resolve a bunch of things. We encountered teams that were literally emailing blobs of code back and forth because they were trying to satisfy some compliance requirement. So like they would email lawyers like, hey, here's the code change that I want to make. Can you look this over? And it was just crazy to us that in 2011, that was still happening.
Yeah, I've heard about data science teams doing all of their experiment tracking in Excel files, and then once they figure out the model that they want, they just send the Excel file to the DevOps team and say like, now it's your problem. So it kind of feels like that was your life back then.
Yeah, pretty much. I think as much as we developers like to gripe about, more modern tools, the reality is that it could be much, much, much worse.
Yeah. And so then you thought, all right, well, I am struggling when it comes to understanding these code bases and seeing the developer productivity just wane. And you decided, why not make a tool out of it? And I guess the question that I have is, how were you so confident that a technological tool was the solution? Because it feels like it's almost like you need a part tech and part education for the coders.
Yeah, definitely. So I think when I took a step back and looked at what was taking up time day to day, it was largely this thing of like, hey, I need to go make some change to this existing code base, but before I can actually get started writing the feature, I have to go and understand a bunch of different pieces that already exist and how they fit together and how they're related to the change that I want to make. And I had some points of inspiration for how I might go about solving that. So I had previously, done a brief stint at Google, and Google has an amazing internal development ecosystem. And sort of like the centerpiece, the shining star of that ecosystem was this tool called Google Code Search. And what Google Code Search provided was the ability to search across the entire monorepo inside Google and navigate the code. So you didn't have to set up any kind of like local development environment to be able to jump to definition or find references. And to me, that was sort of like the bread and butter of what I did day to day as an engineer. And so I started thinking about how could I construct a tool like that, but outside the confines of Google. And in the meantime, my co-founder had also experienced some similar tools in open source. So there's a number of open source code search engines that people have created and used over the years in different communities, OpenGrok and Hound and things like that. And so that was kind of like the rough picture in our minds, like, hey, those tools were useful. How can we build that and make that kind of accessible to every developer?
And so then that was 10 years ago, right? Now, how have you seen that landscape change over the past 10 years, if at all? I imagine there's still banks that are emailing around code snippets because of compliance issues, but what do you feel like the evolution has been?
Yeah, I think the development world has come a long way. I mean, a lot of those banking code bases were kind of a point of inspiration from a pain point of view, and now we're fortunate enough to have a lot of those banks as our customers. Turns out, we were solving a problem that was not just inspired by the pain points we encountered. It actually ended up yielding a solution that was useful to a lot of those organizations. But to your point earlier, I think one of the things we underestimated was just how much education it would take to educate to the kind of like developer mass market about the usefulness of a tool like Code Search. So in the early days, even through till now, I think the developers that like best grok the utility of Code Search are still folks like people who did a stint at Google or people who did a stint at Dropbox or Meta. These are places where they felt the pain point so severely, they built their own internal code search engine, and then it became one of the tools that people rely on day to day. But then a lot of developers, if you haven't worked in an organization like that, you don't have any strong priors for what code search is. So you're like, oh, is it like Control F in my editor, or is it like grep on the command line? And it doesn't really click with people in a short amount of time. And that remains to be kind of like a big, I guess it would technically fall under the umbrella of developer advocacy or marketing for us. This issue of educating the vast majority of developers about how to use this tool and why it's useful to them.
Yeah, it's that jumped out at me right away. Is how you need to have this tool needs to land with someone who understands the value of it.
Yeah.
It needs to be something that people have felt that pain and they realize there's got to be a better way, because I'm pretty sure my friend at XYZ company, he's not spending or she's not spending 2 hours a day just trying to understand what this 5 lines of code actually does, and it's poorly documented, or the documentation that is there says do not change this, whatever you do. It's like, wait, why can't I change this? And you don't want to know, just don't do it. So that feels like something that you are trying to fix. Now, you set out to build a code search engine. I mean, search in 2010 feels like it was, in 2011, it was a whole different beast back then. How has your infrastructure and what you're doing around search changed, and especially just in like the last 2 years? Because with all
Yeah.
of the advances, I would say, in search in the last 2 years, you have to have done a lot of upgrading, I would imagine.
Yeah, definitely. So the domain of search has changed a lot in the past 10 years, and specifically in code search, one of the things that we started out building and prioritizing that I think was a step forward in terms of tools that were publicly available was we viewed it not just as a strict search problem per se, but also, what do you do after you click into a result? When you're trying to understand a piece of code, you click on that result, and then you're staring at a code file, and a lot of what you need to do is do things like jump to definition or find references. You're essentially walking the reference graph of all the different components that fit together. You're trying to understand, what those nodes are and what the edges are in terms of how different parts of code relate to one another. And we started out by focusing on constructing that code graph. So essentially compiling the universe and extracting the symbol tables so that we could execute a jump to definition or a find references request without the user having to go through the rigmarole of getting the code to build, which is an exercise in itself. And so I think like the first big advancement we created was this graph concept. We're essentially like mapping and graphing all the code in the world and feeding that into our product as both a code exploration tool and a signal into the search side of things. More recently, we've been looking at incorporating AI-based signals into the search results and the search relevancy. I actually had a background in machine learning way back in the day, so I did my undergrad thesis in computer vision, but that was like 1 or 2 AI revolutions ago. And so back then, the quality of the models wasn't anywhere near to where we would thought it'd be useful in production. But in the past couple of years, things have just come so far so fast, and we're now in the process of incorporating large language models into many different parts of our product, both in kind of like the generative sense of like, hey, can I ask a question and get an answer, or can I get it to generate some code, as well as baking kind of signals informed by models into the ranking of the code search engine itself.
What do you mean by that? Second use case?
Yeah, so for a long time, the main interface to Sourcegraph code search was supporting string literal and regular expression searches. So the idea is that you type in a partial string match or a regular expression describing the pattern you were looking for. And we supported that at both kind of like a textual level and a symbolic level. So you could actually type in a regex that matched like a symbol name, a function name that you're looking for. And we were smart enough to extract only the function names and eliminate matches that were not symbolic. But more recently, we've been trying to build a query interface that is more accepting of kind of like natural language queries. And there's 2 types of natural language queries. There's kind of like a fuzzy, kind of almost keyword style search that's similar to what you might type into Google. When you search for something in Google, you don't necessarily articulate it in grammatical terms. You just kind of like blurt out the first couple of half-formed words that come to mind, and somehow like the result you're looking for is almost always at the top. And then the second form of natural language is when you actually do articulate it in grammatical terms, and we want to support both types. The former because a lot of queries are just like like SAML, SSO, whatever. Like I'm envisioning like a function in code. I want to jump straight to it. You type out like your first half-formed thoughts, and then we get you instantly there. And then the second part is when you're trying to articulate precisely like, hey, I'm looking for the thing that connects to this thing and that thing. And so you kind of write out a complete sentence describing what you're looking for. And we want to support both. And in order to support those types of queries, you have to incorporate AI into the stack in some way, because otherwise you just wouldn't be able to do that kind of like level of fuzzy matching.
Yeah, it seems like on the one hand, if you're just doing the Google search style, then the AI, I'm not sure where it comes in. I understand on the other side where if you're writing almost like a prompt and you're prompting it to say, hey, where is this? What is it? I want to know what's going on. And you're a senior developer, so tell me in a nice way.
Yeah, so in the keyword style search, where it comes into play is, I think as you know, and as most of your listeners know, there's these things called embeddings that there are the internal representation of language models. It's how the language model represents a string of text. And those turn out to be like pretty decently useful for searching for stuff. So basically, you map the different functions in your code base to embedding space. So you're essentially generating these large numerical vectors that represent, in some sense, the semantics of that piece of code. And then you have the user query, which you also map to that same space. And so you have these two vectors, one representing the user query and one representing a snippet of code. And then you do kind of like a dot product between them, which tells you the distance they are between each other in semantic space. And then when you're doing a search, it's essentially like a nearest neighbor match between those 2 points in embedding space. And so what that allows us to do is it permits us to reveal kind of like fuzzier level results. So in standard keyword search, you kind of have to still get like bits and pieces of the actual keyword. So if I'm looking for like I don't know, I guess to use the auth example again, because I've been thinking about auth recently. OIDC is like an auth protocol. And so if I'm looking for the handler that supports OIDC in my code base, with keyword search, I would probably have to type in like OIDC or OpenID connect, and that would be at least like a partial match against what I'm looking for. But with the more embedding style search, you could type in, SSO handler or SSO handler based on OAuth or something like that. And those terms oftentimes are close enough in semantic space, in embedding space, to yield a search result that you otherwise would not have gotten with just standard keyword search.
You guys must have been using vector databases for a while now. I get the feeling like you were doing these embeddings before they were cool. Is I wrong to say that?
I think we were a little bit ahead of the curve. So we started looking into these signals probably late 2021, early 2022. So we got a head start by a little bit. But I would say like we're not experts in vector databases per se, because a lot of the nearest neighbor searches that we do are actually still within the scope of a single repository. And I think what a lot of people don't realize is that's on the order of like millions of results. And if you're dealing with that magnitude of results, then a for loop works pretty well. You literally just like scan through all the things in your index, and dot product is pretty cheap. And so you can do that, and it's pretty fast. I think we will start to get more into vector databases in the coming months when we start thinking about scaling this nearest neighbor search to a larger corpus of code beyond the scope of your current repository.
Okay, I like that. And now the other piece that I was thinking about as you were talking through this is, can you break down what the actual tech is behind this? Because it feels like I'm not sure if over the last, 10 years, you've had to completely replace how you're doing things, or if you've been able to bolt on these new features on top of it. And so what does it look like?
Yeah, so it's been a combination of both. So we have like a completely brand new product, which is Cody, our AI coding assistant, which we basically built from the ground up. But also we've been able to incorporate a lot of the AI signals into our existing code search engine without rewriting that from the ground up. So our current code search is still primarily keyword based, but it's probably going to evolve into a system that it has kind of a hybrid backend. So where we're using both keyword search and embeddings based search as underlying search providers. So both of those will go and fetch like an overset or a superset of results that might be relevant to the user's query or request. And then we'll have an intermediate layer that's also AI enabled that re-ranks the results from both to bubble up the most relevant results to the top. So happy to chat about either. I think both are extremely interesting problems, both the challenge of incorporating AI signals into an existing product as well as developing a new product from the ground up that takes advantage of what LLMs are capable of these days.
I feel like let's start with incorporating AI into a product that you already had, because I get the feeling a lot of people are in that position, and I like to make the jokes that most product managers are going crazy right now. Roadmaps have been completely thrown out the window, and everybody's asking them what their AI plan is, or if we can add AI to this. Yeah. And so I feel for them. This one goes out to all those product managers. But what did it look like for you? Like, how did you decide to incorporate it in, and then how did you actually make it happen?
Yeah, so how do you incorporate AI into your existing product without upending your entire organization, especially when probably your CEO is breathing down your neck and saying, hey, what's our AI strategy? What's our AI strategy? I think that's a pattern that we've witnessed across the board, and to some extent, we're experiencing that ourselves.
Yeah.
I think we're in this weird position right now where almost everyone sees the potential of these technologies, but not everyone has thought through precisely how they can be made useful in their particular domain area. And so we're in this weird position of there being just like a lot of top-down pressure to adopt, AI in some sense, but with not a lot of clarity on the ground in terms of how to incorporate it. And usually it's the opposite, right? Like, you're in the weeds of the product and you're kind of iterating against user feedback, and you have these insights that kind of like bubble up to these top level insights. Whereas now we're trying to go with like the top level mandate of like, hey, embrace AI. And then it's like, oh, but how? So I don't know if like I'm an expert on this matter, but I think, when we come to trying to like grapple with this task, I think what we found works best is you always got to start with something like simple, I think, and something that's within the bounds of your comprehension. You don't want to go and try to like take on the big dreamy task head on. Like, you don't want to go and try to start building AGI before you have kind of like basic primitives in place. And so for us, I think we started with, from the point of view of improving our existing product, we started with the question of like, okay, what are the capabilities of large language models? There's a couple of interesting applications that seem to have emerged. One is, code generation. Another one is kind of question answering. And then a third one is this kind of embeddings-based search, where you can have kind of this like more fuzzy or semantically informed information retrieval mechanism. And so what are the different products, what are the different parts of our product that could take advantage of those abilities? And then let's start by kind of like rolling in some of these signals in a way that improves upon the baseline. So the first thing we did was take an off-the-shelf embeddings model and do nearest neighbor search on that and see what kind of results we were able to get to augment our existing kind of like trigram regex-based search. And the initial results were pretty poor overall, but with like some glimmers of promise. Like 95% of the time, you're like, why did it think that these two were this symbol was like close to the user query? That's complete garbage. But then there's like in that 5% of the time where like, oh my gosh, like it actually found two things that were semantically pretty close but had no keyword overlap. And so like
Nice.
That was the initial thing, and we iterated on that, and started to fine tune the embeddings model a bit and iterate on improving that. And that was kind of how we dipped our toes into the waters initially.
And I get the feeling you had to have been looking at all different types of use cases. And one that I think about, especially for what you're doing, is, hey, let me highlight this group of code, or let me just like ask of this repository, what the hell is going on here?
Yeah, right.
Getting an answer back, right? What made you not go with that? Or maybe that's something that is on the roadmap.
Yeah, so that's something that we support now in the form of Cody, which is our AI-enabled editor extension. So you can ask Cody a question about your code base. It will do a bunch of searches on the back end, and then answer your question as best it can based on the context of your code base. But in the beginning, we didn't do that because when we started investigating large language models, this was before ChatGPT was released. So GPT-3 was kind of like the most advanced, generally available model at that point. And I think what we and a lot of people discovered is, GPT-3, it had kind of all the basic capabilities that were later found to be present in ChatGPT, but the amount of prompting that it took to unlock those capabilities, you basically couldn't unlock it reliably enough. And so with just the base model of GPT-3, you couldn't just like place relevant snippets of code into context and then say like, hey, can you answer the user's question based on these existing snippets? It would just go off and like, try to complete some other piece of text that it thought was relevant. What changed that was the release of ChatGPT when the fine tuning to make it like better at question answering, and also the kind of logical synthesis capability to the extent that LLMs can reason. That made it a much better model for this use case of like, hey, what the heck is going on in my code? Can you explain it to me?
Yeah. So break down Cody then, because I guess I was under the impression that it didn't have all those capabilities, but it seems like I was totally off. Give me the breakdown on what Cody is, because it's like a chat with your data type bot or QA, where your data is not like a Notion document, it is your repository.
Yeah, definitely. So Cody has a couple of main interfaces. So the two main ones are, one is inline autocomplete. So as you're coding, it will autocomplete the code that you're trying to type based on the context of your code base. So it fetches context from different parts of your code base, tries to take hints from signals in the code that you're writing to determine what other snippets of code might be relevant to pattern match against when it's completing the code that you're trying to write. The second interface is more of like an explicit prompting interface. It's more akin to ChatGPT, although we don't like to say the word chat because I think open-ended chat is actually not a great way to present the capabilities of the language model in the context of coding. So our chat, so to speak, is more like a natural language REPL of sorts, where there's commands that represent common things that you want to do through explicit instruction. Things like generate a unit test, or explain some hairy piece of code, or generate some documentation for a piece of code. And those are things where you would write out an explicit set of instructions like, hey, can you explain this selection? Or I'd like to generate a unit test for this code. And then you hit enter, and then in the transcript, either inline in the code, so where you've made a selection, there's kind of like a text box that will appear there, and you can have a conversation that's attached to a specific range in code. Or you can have it just like general in the sidebar. So think of it as kind of like a terminal of sorts, but it understands like human language. You enter in your query there, and it will either respond with an answer to your question, or if you ask it to generate some code, it will generate some code that follows the instructions that you provided.
There's so many cool things about this. The big question is, does it tell you why you can't delete that one piece of code that is commented on? Never touch this code.
So it can. It can, provided that the underlying context fetching mechanism discovers the relevant pieces of code to answer that question. And so one of the things that we think is unique and differentiated about how Cody works is the context fetching mechanism. So we have this catchphrase that we started to say, which is context is all you need. So it's kind of like a riff on the attention is all you need paper title. But essentially what we found is that the quality and accuracy of responses from Cody, whether you're doing inline autocomplete or answering a question in the more explicit REPL interface, probably like 95% of the time, it's dictated by, hey, did you fetch the relevant pieces of code into the context window of the large language model? Because if I'm trying to answer your question, so let's say your question is like, hey, why can't I delete this piece of code? Now, if underneath the hood we go and find, maybe we do like a find references or go to definition to understand like where that piece of code is being used elsewhere in the code base, and then that snippet of code shows that the function is being invoked in a certain way, then using a language model like ChatGPT or Claude or an equivalent chat-based model, those models are generally good enough at doing kind of like some primitive form of logical reasoning where I can say like, oh, like here's a comment saying like, don't change this.
Ops. You have to immerse yourself in the MLOps content. The best way to do it is to subscribe to the MLOps.community podcast. So, good luck and keep learning.
And then here's an example in the code of using that function in a particular way. And then it's able to synthesize those two facts into an answer explaining why that comment exists. On the other hand, if your context fetching mechanism misses one of the snippets of code, let's say like it can't find any usage examples for whatever reason, then the model will just more likely than not make up some BS answer as to why that is, you know?
Yes. Yeah, and I get the feeling it's like, if only it was that easy where it was that piece of code could be linked back to another piece of code. I feel like on those really hairy databases code bases, what you get are like 5 different layers of code being dependent on other code. And then what you have, I don't know, I would love to see if the search could pull up every piece of it and follow the breadcrumbs around.
Yeah. So the short answer is today it doesn't, because we haven't made it good enough yet. But we're on the track to getting there. So essentially the intuition that we're following is, you know, if you gave a human that task, like let's say you dumped a human into this code base and said like, hey, we need to change this code, despite being a comment that says like, do not change this code for these reasons. You know, there's some feature we need to build. You as like the hapless human would have to go in, like you would use that as your starting point, but then, you know, you might think of some searches that you might want to do, like, like related pieces of functionality to surface potential needles in the haystack. Or you might do like a find references or a couple of go-to definitions to do kind of like a search around and find surrounding code that's relevant. And over time, you'd incorporate those snippets into like a general picture of what's going on in the code base until you have enough relevant snippets of code kind of paged into your working memory to make an attempt at actually editing the code in a way that doesn't completely break the system. And so that is essentially what we're trying to make the AI do. I don't think like the AI is not going to come up with some like magical insight. You know, it's not like you dump the entire code base in and it just magically pops out with the answer. Like that's not how things work. Despite, you know, all the hype around AGI, I just, you know, these LLMs in practice just aren't there yet. And so what we are building is basically a system that can replicate the process of how a human understands and surfaces relevant pieces of code in the code base. And then over time, like the first step is we have to have reliable primitives. So like the answers that are answerable with like one hop, you know, like a find references or go to definition request. Like if the answer is answerable based on the snippets you can get from that one hop action, those are the ones that we can do a reasonable job of answering now. And then once that's reliable enough, we'll do 2 hops and then 3 hops. And then at some point we'll work our way up to maybe this thing that feels kind of like semi-autonomous in terms of how can it can explore and discover things in the code base.
It just reminds me, I heard a story back in the day, and I can't remember where I heard it, but it was something along the lines of an engineer looking at a code base and reading the comment, and the comment said, "Do not delete, you stupid idiot," something like that. And the guy looked and it was like, man, that's pretty harsh. Like that seems like some really aggressive language for this simple function. And where's this function even? It's not useful. Let's like try and dig into it. And they were digging into it for the longest time. And they came to the conclusion that it wasn't actually being used anywhere. And so they went ahead and they said, you know what, like whoever did this last was exaggerating, or since then the code base has been updated and, you know, there's no more dependencies on this function. And they deleted the function, and then it crashed the whole system. and they had to roll back. And from there, they went and they dug up who wrote that comment. Turns out it was the same engineer who deleted it. It was
That's
like
hilarious.
them talking to themselves, but like 3 years back, they were saying it, and they probably did that whole thing and went through that whole cycle. And so they had to go through it again. So it's one of those things where that's what Cody's for.
It's one of those things. And look, like, I don't think the AI will ever get to the point where it's like, oh, like, I just understand everything there is about the world, so I know why this thing needs to stay because of, I'm generally intelligent. I'm super intelligent. And by some magic, I just know the answer. What it's going to do is just allow you to more rapidly explore the channels and the pathways that you know that you should be doing when you're trying to like get a comprehensive answer to a question that you have anyways. But you don't end up doing a lot of that now because you're like, I've already sunk like so many hours into trying to figure out this one thing. I haven't even written a single line of code yet. It's essentially like accelerating and automating the toilsome parts of the job so that we can do a more thorough part of the job that humans are actually good at, which is, the kind of like high level, like, hey, I need to make this change to the code base.
So when you think about developer productivity, and as you're talking about augmenting the developer's abilities and being able to take anybody on the street, well, maybe not on the street, but anybody that is in a software development role, and then cutting out all of that cumbersome time that goes into the researching of figuring out like what is actually going on here, how can I read this code. It's much more, what I'm understanding is it's much more than just a Copilot like experience where you're building out autocomplete and okay, cool, I'm going to write this function, I'm going to add this to it. What you're doing is you're helping interpret, you're helping answer questions, you're helping find different pieces in the code base that there's breadcrumbs that have been left behind. And so now, as you think about developer productivity, I know you mentioned before we hit record that you feel like we're in this Gutenberg type moment. Can you explain that a little more?
Definitely. Our core thesis is that the core of being a software creator, a programmer by today's standards is about understanding code and then writing new code based on that understanding. And so like that is the thing around which everything evolves. It's understanding source code and then outputting source code to build features and functionality for the tool or product that you're creating. And that should really be the centerpiece of all the other tools that you use, because that's the core kind of like inner cycle of what you do day to day as a programmer. Your job is kind of going through this loop again and again of like understanding, synthesizing the code into your kind of worldview, and then making an update to that worldview by editing the code. And so that's the tool that we're building. We really think that this is a tool that will be kind of like the centerpiece of most developers' workflows. Now, to your point, this kind of like Gutenberg moment, I think there's this question of like, what is a software developer in like 5 years or 10 years in the world of AI? And we actually think that there's a huge opportunity in front of us to kind of expand the franchise, so to speak, of the set of people in the world that are able to create software. If you think about it, there's kind of like this tiny like priestly caste of people that can speak the language of computers right now, and we call them programmers or software engineers, and 99% of people aren't able to do that. So the way they interact with computers, the way they're able to leverage the capabilities of computers to improve their daily lives, is limited by the software that's created by that kind of like tiny priestly caste. And so what happens in a world where we give that power of software creation, the ability to like customize behavior and implement your own functionality, implement your own automation, to the remaining 99% of the people in the world? And I think that's definitely within the realm of possibility now, given the advent of large language models. Large language models are essentially like the world's best mechanical translators. They can translate from, English to German, or to whatever human language you prefer. And they're also great at translating natural human language into programming languages as well. And so I think in 5 to 10 years, we'll think about a much broader set of people being involved in the process of creating software. And we'll need kind of like an entirely different way of thinking about how that process goes and what sorts of people are making contributions to this kind of like code base.
Yeah, because if it's as easy as making an edit to Wikipedia, it's a whole different playing field, right?
Yeah.
And so I like what you said, how it's almost like there's this elite class that understands what's going on when they look at GitHub, and they are able to speak this language. And so if you can bring that to the masses, what is that going to do for the products that we create?
Yeah, 100%. And we need tools that allow this translation to happen reliably. So I think, today's world, it shows a lot of promise, but we're still not quite at the point where, I can hand, let's say like my dad a computer. He's not a programmer. He has no background in programming training. We're still not at the point where he can go and basically talk to the machine and get it to implement some piece of automation. There's still like a little bit of debugging knowledge that you need to have, a little bit of ability to kind of like manually adjust the code that AI emits. But I think by building a system that has both LLMs and this kind of notion of like checking correctness, and that's one of the things that Sourcegraph has traditionally been good at, because we have kind of like a compiler level understanding of the code. You could envision a system that is able to kind of like iterate and self-correct on itself and reliably generate code that, edits an existing piece of software based on some piece of natural language instruction. And so that'd be really cool, because then, I could say like, Dad, like, you don't like, you're missing some feature in, Google search or, some other piece of software you use. Hey, go and like talk to your computer, describe what you want, and it will actually like figure out how to do the thing that you're trying to describe to it.
Well, so here's where I find it funny, because watching the different YouTube videos that talk about how you can leverage LLMs to code now, or nobody needs to actually know how to program because you can use LLMs and that's all you need type thing.
Yeah.
But then they proceed to go into, okay, and then I just, I create this regex expression, and you're like, wait a minute. How did you know how to create that how did you know how to ask the LLM for that specific thing? And it's like, you wouldn't know how to ask for these things or how to phrase your prompt unless you were actually a programmer. So it very much, in my eyes, is still at that clunky phase where, it's cool if you know what's going on, but if you don't know what's going on, you're still kind of SOL.
Yeah, we're still in the early days, and right now the immediate applications that are actually productionizable are still mostly for professional software engineers. I think it's kind of like those old cooking shows, if you remember, growing up. Like, the person would like do all the prep work and show you how to chop the vegetables and like put everything into a bowl, and they put something into the oven, and then like they take out immediately above it like, hey, here's the fully formed souffle or whatever. And then you would do the same thing, and yours would come out looking nothing like that. And you're like, okay, there were some steps that were omitted in this process. And I think right now humans still have to fill in those gaps, and those humans still have to understand. They have to be literate with programming languages. But I think in a couple of years we'll get to the point where we have systems that are reliable enough that can do kind of like the automatic checking for you, so that people who don't consider themselves professional programmers or software engineers can actually start being more reliable contributors to code bases.
Well, so what do you think then is the argument for why that hasn't happened in the low code, no code movement? Because that's been around for a long time, right? And I guess whenever I've used low code, no code, it's kind of like that same thing where I get overloaded with complexity, or I still feel like you have to have a bit of a systems mentality or a systems way of thinking about it, and a ton of patience to learn how the no-code tool works.
Yeah. So I think traditional low-code, no-code tools were an attempt at solving the complexity of software creation through the introduction of abstractions. And that's indeed how most people have tried to pare down the complexity of software development in any capacity, right? Like introduce an abstraction layer that hides some of the messy detail, prevents the user from shooting themselves in the foot, and kind of like guides them along a happy path of development. I think the challenge with that approach is that there is a cost to the abstraction, right? What you get is more guardrails, but it comes at the cost of expressivity. And this is something that people have noted again and again with tools like that. It works as long as you're trying to build the thing that they built in the demo, right? But as soon as your requirements go beyond what the platform has anticipated supporting, then you kind of hit a brick wall. There's no way to get around it, or you have to, dive so much into the weeds that it would almost be easier to ask a professional engineer just to write it in kind of like a regular programming language. I think language models have a potential to create the best of both worlds, where maybe in the future when you're trying to like build an application and you're not a professional software engineer, you don't understand how to interpret C or Java or Python, you can just express what you want in natural language just in the context of a regular code base. So there's no like no code or low code platform. There's no piece of abstraction sitting between you and the code. But what you're doing is you're articulating what you want in a natural language. It's generating code for you. It automatically checks that it works. And then it can kind of explain back to you the code that it generated, sort of explaining, the detailed things it's doing. How does that relate back to your high level piece of instruction? And so I think that is, to me, a much more compelling vision of the future, because then we can have our cake and eat it too. We can have everyone be involved in the process of software creation without sacrificing any of the expressivity or the power of a raw Turing complete programming language.
Yeah, those guardrails, that it's exactly that. Like, you try and mess around with it. It's a lot of the same complaints that people have when they're using a managed service. It's like the best part of a managed service is that it's managed. The worst part of a managed service is it's managed. So you can't get underneath the hood when you really need to, and you want to go, and that maybe 80% of the time it's magical. And then the 20% of the time you're like, I really wish I could just turn a few knobs and change a few things on this.
Yep, absolutely.
So when you think about how you're building, especially Cody, I wonder if you've gotten into the idea of, what if we could just make agents that would go and do what people want done before they even have to go and do it themselves?
Yeah.
Have you gone down that path?
Yeah, absolutely. I think agents are all the rage right now. And I think there's a ton of potential there. I think there is a future where we have a bunch of these agents, and I think of them more as they're just computer systems, right? At the end of the day, where the input is some piece of human instruction, likely natural language, and then a series of actions that performs on behalf of the human, involving. And it could be human in the loop or human out of the loop. So, either completely automated or kind of like asking you for feedback along the way. I think the world we live in today, I guess I would say like, okay, like that's the end state, right? And the question is, how do we get there? And I think what you kind of have to do is you have to start with kind of like the building blocks. Like, what are the building blocks of agents? So agents are these kind of like multi-step things that happen in response to a query or a prompt. In order to get to multi-step, we have to start with reliability at a single step of that process. And we're still in the stage where that single step process is still fairly unreliable. A lot of people talk about language models being quote unquote usefully wrong, in the sense that they will hallucinate from time to time, they will mess up from time to time, but it's okay because they're still more useful than not. Like even if it invents an API that doesn't exist, you as a human can still be like, that doesn't exist, but like the rest of the code you wrote is still helpful. I can pattern match against that.
That's good.
Once you start trying to compose those into longer and longer chains of thought, the reliability and the accuracy does tend to matter more, because think about each time, each step of the process, you're rolling the dice, so to speak. And if you hit an error mode, then your thing will quickly go off the rails. And so for a one-hop process, 70% reliability, maybe that's tolerable because it works well enough most of the time. But once you're, 3 or 4 steps into it, what's, 0.7 to the fourth or fifth power, at some point decays to 0.
Yeah.
And so I think where we are with agents right now is we're still at the point in working with language models where the longer chains of thought are just too unreliable to rely on for day-to-day use or production use. I think we're maybe still at least a year away from there. And what it's going to take to get more reliability, I think, number one is improvements to the model layer. So training and fine-tuning models to be more
agent-friendly.
Agent-friendly, exactly. Or like domain-specific. Like if you're training an agent to use APIs, right? Like there's a lot of low-hanging fruit, I think, left for enabling these to be better users of APIs and to generate working code. And then there's also, figuring out how to compose them with other systems, like things that might do static checks or check the correctness of the output, and might fetch information or context, like Sourcegraph does, for the agent to help improve the accuracy.
Yeah, it doesn't feel like there's a clear stack for agents yet. And if it does feel like, on the other hand, we're getting a stack for using LLMs, and that is becoming like vector database is the champion in this one. And then you've got your SDK libraries, and maybe you've got some prompting or some explainability or some kind of tool to keep the guardrails on. And then of course the large language model is there and ever present.
Yeah.
But when it comes to agents, I feel like what you just described, there hasn't been, or maybe I just don't spend enough time diving into the tooling around agents.
Yeah.
But there hasn't been that idea of like, here's a clear design pattern when you're trying to use agents.
Yeah, I think that's absolutely right. I think that's largely because no one has figured out how to do it reliably enough.
Yeah.
And so there is no like example of like, hey, like this works awesomely and it supports all these things in production. At the point in which like that becomes a thing, then I think there will be like at least a few open source projects or frameworks that emerge where it's like, okay, we can point to at least one application that makes use of us that people use day to day or they rely on in a production environment. And I think right now it's mostly just ad hoc. Like everyone building with language models is kind of building their own proto frameworks internally, because we're still experimenting with exactly what combination works well in practice.
You did mention one thing when it comes to dealing with agents and how you feel like there's a lot of possibility for creating a fine-tuned model that just deals with APIs or API creation.
Yep.
When you were building Cody, are you using GPT on the back end? Are you using Claude? Did you bring it all in-house, and are you using a open source LLM?
Yeah, so we use LLMs in a few different places in Cody. So for the code generation and the chat-based generation, so the Q&A, we can use either Claude from Anthropic or GPT from OpenAI. We're also planning on supporting some of the newer open source, Llama-based models there as well. And then for the retrieval aspect of it, which is generating embeddings and using those for search, we're using a combo of OpenAI embeddings and open source embeddings that we've kind of fine-tuned for our purposes. And so we are kind of getting into the model layer, and we've been a little bit circumspect about investing there because I think there's a lot of good stuff available off the shelf currently, And in working with these things, we think a lot of the low-hanging fruit is still in the realm of retrieval augmentation. So like, how can we improve the quality of the context that we feed into the models? And so I don't think we've exhausted that yet. And the fact of the matter is you're able to iterate much more quickly when you're only dealing with model inference and feeding in different pieces of context and playing around with the context retrieval mechanisms than training a model or fine-tuning a model, because that involves a whole cycle, like gathering data, cleaning the data, running the fine-tuning, seeing the outputs. And so we probably will get there eventually, but right now we're mostly a retrieval augmentation shop.
I always joke that fine-tuning is something that sounds so good when you say it, and everybody's just kind of like throwing it out there like, yeah, our next step is we're going to fine-tune a model. And it's like, do you know what goes into fine-tuning? Have you really tried to do this before? Because it's not like just uploading your photo to Lexica and then getting like some cool shit passed back to you 15 minutes later. That's not fine-tuning. As much as Stable Diffusion may have made you think it is, that's not really what it is with LLMs.
Yeah, it's almost like I feel like I've seen it in some capacities where it almost seems like a marketing ploy, where like, oh, we're doing the real AI because we're fine-tuning. And I think we will get to fine-tuning at some point, but we have this mindset, like I said in the very beginning, like when you're getting into AI, like my recommendation would be start with the easy things first, start with the things that have the ability to add immediate value.
And so how are you dealing with rate limits and failovers or failovers? Like, what do you do about that when all of a sudden OpenAI or Claude doesn't want to respond anymore, and you're just like, well, guess we can't call support?
Well, actually, we can call support. So we have, good, strong enterprise relationships with both Anthropic and OpenAI in place. And so
you're the lucky ones. You are.
I suppose we are. Both of them have been very helpful as we've kind of built out and scaled Cody up. But the short answer is that it's just like another external API, right? Like if you're a product that has any sort of external or cloud dependency, this is something that you have to manage as part of your platform. And there is downtime at some points. And that's something that you have to convey to your customers that now and then there might be downtime in service. I think the good news is that we're still in kind of like the early days of AI. So a lot of folks do have kind of like a general tolerance of like, hey, it is kind of like the wild, wild west right now, and things are moving quickly. So, if things go down for a period of time or there's some turbulence along the way, then that's just part of the journey.
Well, I feel like you already are doing a lot more than most people think about when you have Claude and ChatGPT or just GPT to hit. Mm-hmm. And so I guess you can load balance a little bit that way.
Yeah. I think one of our philosophies is we do want to support multiple language models because, not just for kind of like the reliability and robustness side of things, but, as new models get released, we want to be able to incorporate the latest and greatest into Cody.
But you're not, like if I am playing with Cody, I'm not getting both of those answers, am I? It's just hitting one of the APIs? Or are
Correct.
you, because I imagine there's a lot of roads we could go down when it comes to evaluation and how you're evaluating which ones are better. And
so right now you're getting either one of those. We're not doing both. We're not trying to like compare and contrast anything at flight time. I think part of it is just it was easier to implement that way. And then another part of it is also, I said before, context is all you need. And what we found is there are differences between the two models in terms of what their relative strengths are. But by and large, the context is what makes the difference. And so like the differences in terms of like how good it is at generating code in this language or that, they largely diminish or even vanish once the context fetching quality is good enough in a given language. Because what the model then does is just pattern match against the snippets that you feed it. And so it relies a lot less upon its kind of like unique memorized knowledge.
Yeah, that's fascinating. So it really gives it less roads to travel, or I almost look at it as you're closing the possibilities that it can answer back with. You don't give it anything. It's not like, hey, answer me with anything that you've been trained on. It's like very, very specific. And the more specific that you can give it, the more specificity that you can give it, the better it's going to be and the more accurate it's going to be.
Yeah, exactly. I think like the rough analogy is like, let's say you had two humans and they're both pretty smart. And one might be better at, Python and the other one might be better at Ruby, but you give both of them access to, a code search engine or something like Google, and then you ask them to answer a question. The answers are going to be a lot closer if they have access to the search engine than if you ask them to just write it from memory or answer the question from memory. Yeah.
Well, dude, this has been awesome. I know we've went way over time, so I want to thank you for being incredibly open about all of this. And for anybody out there that has not tried Cody, highly encourage it. Have some fun. Go and play around with it. Bring it into your code base and see if it will tell you why you can't delete that one fucking function that's been there since the beginning of time.
And let us know, too, if you end up trying it out. We have a Discord that's available, and we love to hear feedback, especially the critical feedback that allows us to make the product better. And thank you, Demetrios, for having me on. This was an awesome conversation. Had a lot of fun.
Excellent. Yeah, I mean, when it comes to feedback, I was thinking about that. When you do start incorporating Llama in there, I imagine that's going to be excellent if you can run them both at the same time. And you can say, all right, we've got Claude and we've got Llama. Which one was better? Yeah. And then you can start seeing or you can start training, fine tuning. It's just as easy as a fine tune, dude. It's all good. Your Llama model.
Yeah. You can ask them to rate each other too.
Yeah, exactly. Anyway, that's it. That's the pod. We'll end it there. Thanks, man.
All right, cheers.
This is Skylar. I lead machine learning at Health Rhythms. If you want to stay on top of everything happening in MLOps, subscribe to this podcast now. 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 Now.